says when calcium carbonate is added to hydrochloric acid, calcium chloride, carbon dioxide, and water are produced. How many grams of calcium chloride will be produced when 26 grams of calcium carbonate are combined with 12 grams of hydrochloric acid? Which reactant is in excess, and which grams of this reactant will remain after the reaction is complete? So classic stoichiometric question here. So this is number 3. So let's say we have CaCO3 calcium carbonate plus hydrochloric acid will yield, I have calcium chloride here plus water and plus CO2. Okay, so we have all these guys here. And it's asking us how many grams of calcium chloride will be produced here. So I want to look for the mass of this guy here when I have 26 grams of calcium carbonate. So this is the mass. Calcium carbonate is 26 grams, are combined with 12 grams of hydrochloric acid. And again, I want X here, right? This here is going to be my unknown here. So I want to find the mass of calcium chloride. Or sorry, grams of calcium chloride, yes. So I have a mass here. What I want to find here is I want to find which of these guys are the limiting reagent. And then that will determine how much mass we're going to make here. So I have mass here, which means I'm going to have to find the moles of calcium carbonate and hydrochloric acid here. So I'm going to do the molar mass here. So molar mass of calcium carbonate is going to equal, so let me write this down. It's going to be, let's see, Ca here is 40, I believe. 40.078. So I have 1 calcium. So it's going to be 40 I'm going to see if I can fit this all in a chart here. 40.078 plus, I have 1 carbon here, which is 12.011 for the molar mass here. So 12.011 plus, I have 3 oxygens here, so 3 times 15.999 will give me my molar mass here. So 3 times 15.999. This is going to equal my molar mass in grams per mole. So this is 40.078 plus 12.011 plus 3 times 15.999. This is going to be a value of 100.086. And this here will be my molar mass of this compound. So 100.086. 100.086 grams per mole. So this here is my molar mass of this. And what about my molar mass of my hydrochloric acid? So let me draw a line here. Kind of not good, actually. Let me draw it like this way here. And let me rewrite this guy. 100.068 would be here. 100. Oh. 0.68 grams per mole. Again, I have 12 grams of hydrochloric acid. I want to find the molar mass of hydrochloric acid, obviously. So hydrogen, I have 1 hydrogen here, so it's going to be 1.01008. So 1.008 is my molar mass of hydrogen. And then I have my molar mass of chlorine as well, which is 35.45. It's going to be 35.45, which is going to equal, I add both of these numbers up, 1.08008 plus 35.45 will give me a value of 36.458 grams per mole. So this here is my molar mass of calcium carbonate and my hydrochloric acid. And what I can do now is I can find my moles, right? So this here was my molar mass. Let me write this in blue here. I want to find the moles now of these two guys here. So the moles is simply going to equal my mass divided by molar mass, right? So N here equals mass divided by molar mass. And this is going to equal, again, mass of, so calcium carbonate at 26 grams divided by 100.068, right? So 26 grams there's the mass of calcium carbonate. I'm going to divide that by the molar mass of calcium carbonate, which is 100.068. I'm going to get a value of 0.2598. So 0.2598. And this here is going to be moles. And then for this guy here, and what am I going to get for this guy here? So I have 12 grams divided by 36.458, which is going to be the molar mass of hydrochloric acid. So 12 divided by 36.458. And I'm going to get a value of 0.32, 0.3291. 0.3291 moles. And then what I have to do now is I'm going to have to compare the mole, the coefficients first before I compare the mole values. So as you can see, I have calcium carbonate here, but then I have two hydrochloric acids here, right? So what I'm going to have to do is I'm going to have to actually divide this number by 2 because I have a coefficient of 2 here. So this here, this mole, I would have to divide it by 2 to get what is 1:1 for the mole ratio here. And as you can see, they did the mole ratio as well, right? So what they're doing here is that they are going to divide this this value by 2 here. So let's see. So they got, let's see if they got this solution correct. 0.26 and 0.3. I got 3291 here, but I think their molar mass is off by quite a bit. It's 36.5. I wrote 36.458 here, so they're actually slightly off here, which is, oh, they wrote 13 and not 12. This is 12 grams. Okay, so that's why their numbers are off here, but it's okay. We can still work with this here. What we can do is, again, we're dividing this number by 2, right? So this is the mole-to-mole ratio here. So you can think of this as I can either divide this by 2 or I can multiply calcium carbonate by 2 here to figure out that. So if I want to do that, I would actually, in this case, what they're doing, they're multiplying this by 2, which is fine, or I can divide this by 2. So in this case, I can just follow their strategy here and multiply this by 2 here. So we get 2n here, which is going to equal, and we already know that this here equals 2n, right? So this is already, because the coefficient is already 2 here, so I can simply have to write 0.2598 multiplied by 2, which is going to be 0.520 moles. And all I'm going to do now is I'm going to compare these two values together, right? As you can see, this is 0.520, this is 0.3291, which means this here is going to be my limiting reagent. Therefore, limiting reagent, and this guy here is going to be my excess reagent here. So the question is, which reactant is essence, is excess, sorry, is going to be my calcium carbonate here. And which one would be limiting? This would be the limiting reagent as well. So knowing this, what I can do now is I can solve for this calcium chloride, right? If this is here is my limiting reagent, I can solve for my calcium chloride. So what I have here is what they're doing here is the moles of calcium chloride equals the moles of calcium chloride divided by hydrochloric acid here, the mole ratio here. So if calcium chloride divided by hydrochloric acid, it's going to equal 3291 here, which is good. And then what I can do, and then they didn't actually finish this problem here, which is kind of concerning. But this here, I'm going to have to multiply. I'm going to have to basically multiply this by half. And that's why I wanted to multiply this by half. So let me redo this. I don't really like what they did here because it doesn't actually help us go into our solution here. So we know that this here is excess and this here is the limiting. However, if I want to multiply this guy by half, because to get per mole of my hydrochloric acid here. So I'm going to divide this number by 2. It's still going to be a limiting reagent. I just like how I simply like dividing by 2 to get everything in terms of 1 mole here. This is going to be 0.164 or 165 if I were to round it, moles. And again, this is still my limiting reagent, right? Limiting reagent. So you get these guys, this is excess and this is limiting here. So that's fine. And then what I can do now is I also know my multiple ratio, right? So I know that this here is also going to be 0.165, right? This calcium chloride is also going to be 0.165 moles. So all I'm going to have to do is work backwards to figure out my mass, right? So I have to figure out the molar mass of calcium chloride. So that's very, very easy. What I can do is I already know the molar mass of calcium, which is 40.078. Plus, I'm going to have 2 chlorines, right? So I have 2 times, and chlorine here, I said that was 35.45 here. So this is going to equal the molar mass of calcium chloride, which is 40.078 plus 2 times 35.45. So that's going to give me a value of 110.9978 grams per mole. And finally, I can solve for my x value, right? And this x value is simply, if I were to rearrange this equation, so if I know that moles equals mass over molar mass, then mass here has to be moles times my molar mass here. So I'm 0.165 multiplied by 110.978 here. So using this, so the mass of CaCl2 is going to equal the moles of CaCl2 divided by the mole, or multiplied by the molar mass, sorry. Moles of CaCl2 multiplied by the molar mass of CaCl2 here. And this is going to equal, I'll just finish it off here, I guess. Moles is, again, 0.165, like so, and the molar mass is 110.978 grams per mole here. And this is going to equal my answer. So this times 0.165 is going to equal 18.31. And this here is going to be my answer for this problem. So I have 18.31 grams. And if I were to care about the significant digits here, I'm looking at my significant digits. I have 12.0, so I have 3 significant digits. So therefore, the answer should have been 18.3 grams of CaCl2. And this here is the correct answer for this solution. And they actually did not complete this answer, so that's fine. So I'm going to say solution is incomplete. Incomplete. So they got this right, which is good. So they did this part right. Or actually, no. They actually divide by 13 instead of 12 here. So let me copy and paste this. And this here should have been statement should have been 12 grams HCl, not 13 grams of HCl. So therefore, this would have been 0.3291 here. Which would equal 0.165 moles of CaCl2. And then what we can say when we know the mass of CaCl2 is going to equal moles of CaCl2 multiplied by the molar mass of CaCl2. I'll just finish off this problem for them. I'm going to say that the moles here is going to be 0.165 moles multiplied by 110.978 grams per mole. And this is going to equal 18.3 grams of CaCl2. Therefore, let's see, it says here we are producing 18.3 grams of CaCl2 in the reaction, and CaCO3 is the excess reagent. So solution is incorrect because they failed to complete the question here.